An airplane is flying at a velocity of 200 kilometers an hour due east. It encounters a crosswind blowing at 50 kilometers an hour from the south. This is meaning that the wind is blowing north. What is the resultant velocity of the airplane relative to the ground? The best way to visualize this problem is to graph it. The airplane is flying with a velocity of 200 kilometers an hour due east. Then it is going along the x-axis. The crosswind is blowing at 50 kilometers an hour from the south, meaning that the wind is blowing north. Then it is going along the positive y-axis. And the resultant velocity of the airplane will be somewhere out here. In order to find the resultant velocity of the airplane, we must find the x and y components of the velocity of the airplane and the wind. The x velocity of the airplane is equal to the magnitude of its velocity, 200 kilometers an hour, as it is going directly along the x-axis. The y velocity of the airplane is equal to 0 as it has no movement in the y-axis. The x component of the wind's velocity is equal to 0 as it does not move in the x direction, while the y component of the wind's velocity is equal to 50 kilometers an hour. The x component of the resultant velocity is equal to the sum of the x components of the wind in the airplane. This gives us 200 plus 0, or just 200 kilometers an hour. The y component of the velocity is equal to the sum of the airplane and the wind's y components. This gives us 0 plus 50, or just 50 kilometers an hour. The velocity of the resultant component can be found by taking the square root of the sum of the x and y components squared. This gives us the square root of 200 squared plus 50 squared. This equals 206.16 kilometers per hour. To find the direction of the resultant velocity, we'll use the trig function tangent of theta is equal to the opposite over adjacent legs, and theta is equal to the inverse tangent of the opposite over adjacent legs. Our opposite leg is equal to the y component of the velocity, and our adjacent leg is equal to the x component. Plugging in, we get that theta is equal to the inverse tangent of 50 over 200, which equals 14.04 degrees. So our final answer is that the resultant velocity of the airplane relative to the ground has a magnitude of 206.16 kilometers an hour and is 14.04 degrees relative to the positive x-axis. If you found this video helpful, don't forget to leave a like, subscribe, and let me know in the comments what topics you'd like to see next. Thanks for watching.